Good morning. We are from SVS Embedded. The project title name is called CAN based accident avoidance system, or else CAN based collision avoidance system. Uh, in this project we are using an CAN protocol, and we are using an ultrasonic distance measurement sensor. This is a HCSR04 module, and we used two LCD displays. So one is for the transmitter unit and another one is for the receiver unit. So whatever the data is processing going on to the microcontroller in transmitter unit, that should be displayed onto the LCD. So basically, first of all, the block diagram side here. So we used in transmitter section, so power supply, that microcontroller 80 mega 16 and 16 cross 2 LCD display. This is an character LCD display, and here we used an ultrasonic distance measurement sensor. This is a front sensor, and it can detect up to 1 meter distance. And here we used one MCP2515 CAN controller, and we are used one MCP2551 CAN trans receiver, and whatever the data it is coming from the receiver unit, that was controlled unit. Here also we used one CAN MCP2551 CAN transceiver, CAN controller, and 2551 CAN trans receiver, CAN controller, and we received 80 mega 16 or 32. So whatever that the display, that should be displayed onto the 16 cross 2 LCD display, and it is controlled by L293D driver IC. This is quadruple HBG driver IC. For DC motor driving purpose, we are using two DC motors. It's an one both sides. This is called DC motor 1 and DC motor 2. So coming into the hardware side, first of all we are used one transformer. It's a step down transformer. So otherwise we can use the battery, or battery. It's an 12 volt 1.3 amps battery. Otherwise if required from your side, you can use any battery power supplies for these motors. See, whatever that you are using the battery power supply, you have to give these two. So these two are called the input. So here we are using bridge rectifier. Into bridge rectifier, these are if there is if we are giving the AC power supply, it converts into the DC. Otherwise if you are giving the DC, there is no polarity. The bridge rectifier give the polarity. So after that we are using one 1000 microfarad by 25 volt electrolytic capacitor. Okay, it's an filter capacitor and same. And after that we required LM7805 regulator. This regulator will regulate 9 volts to 5 volts or 12 volt to 5 volt, and it was we are used one 80 mega 16 microcontroller. And this microcontroller having 40 pin IC, total 4 port. Each port consists of 8 pin, total 32 input output pins. And here we have in port A, B, C and D. Port A we are not using. Port B is connected with ISP, and port in ninth pin we have a reset switch. Here I was given the reset switch. If the program instructs, we have to restart this. So here I am using one crystal. This is 11. This is a 16 megahertz crystal. This is the heart of the circuit for the microcontroller to generate the clock pulses to the internal CPU to run the program. And port C is connected to the 16 cross 2 LCD display. It's a character LCD display. Whatever the process is going on to the microcontroller, that should be displayed onto the LCD. And here I was used one ultrasonic sensor. It's an 4 pin ultrasonic. In that VCC and a trigger and echo and ground. Trigger means here we are connected port to D.5 is the OCR1A trigger, and echo is port to D.6. We are getting the data, and that was connected to the microcontroller. And one is the transmitter, and another one is the receiver. It can sending the sound waves of 40 kHz frequency, and at the same time it was received also 40 kHz of frequency. Both this is transmitter and this is and those are connected to the port D. And after port B is connected via SPI communication to the CAN controller. This is the CAN controller and this is the CAN trans receiver. The data is sending through wired, and at the same time it was connected to the CAN trans receiver, and the same time it is connected to the CAN controller, and whatever the data that was given to the microcontroller. Okay, that was given to the microcontroller, and at the same time the microcontroller will receive the data and display onto the LCD, and after that what it is checking for the data and giving the buzzer. If the for the distance the L293D, we are going for the PWM technique, pulse width modulation technique. If the motor there is no vehicle in front, that robot will be move fast. If the vehicle is coming any near, like an 80 meter distance, it will less. Some of the speed will be around 80 kilometer per hour, and 75 kilometer 60, the distance whichever the 80 meter, 80 centimeter, 70 centimeter, 60 centimeter, 20, and it will take for right or left. And after that it is in 10 centimeters, the robot will continuously give the buzzer alarm, and it will be stop. If the vehicle moves now, it will be continuously make it will take us the left direction or right direction, it continuously moves. See, there is no vehicle. Let us first of all we will see on the output. So first of all it will display the data like CAN based collision avoidance system, for the automobile, and there is no vehicle. It continuously gives there is no vehicle. If I giving the hand to that one, see the data which is coming to the near 30 centimeter, it will move only one motor, and otherwise if it is in a far now, it will move, and if it coming near now, it will give the buzzer, and it is 10 centimeter now, it will be stop. Okay now, and it is continuously moves. When my hand is far now, so here my hand is very far, the robot will be moves. If there is no robot, the robot will be moves very fast. If the vehicle is coming, if the vehicle obstacle is coming near to the ultrasonic, according to the sensor, that gives the buzzer. Okay no? At the same time in transmitter also we will get that same data, and after that receiver also we will get the same data. Okay, so if there is any doubt, let me know to SVS embedded.